I think this is, again, a central design consideration, right, when you're building AI agents. And I think we can maybe break this down into like three parts. So the first part is the task itself. And you gave an example of a task, right? So how important is it for you to get the task absolutely right? Now, in ChatGPT, if it gives you a slightly different answer, it's like search, right? You're getting information. You're not essentially making a decision. So you're okay with some level of non-determinism because the human mind is able to correct for that, right? The other end of the spectrum, if you're essentially betting on this AI agent to execute a task consistently, it could be, a enterprise workflow, a backend workflow, right? It could be code generation, or you're essentially a customer service interaction agent. You cannot have that level of non-determinism. So the way, so that's one thing. Like, how do you define the task? And I think that's a key question to ask. The second aspect that you want to look at is, okay, now that you say, let's say you have a task that you need to be accurate, right? And it's also, again, important to understand that AI agents are not all about just LLMs. There's a lot of existing software. There's a lot of reusing, machine learning models, predictive models, which are deterministic, right? As well as the classic things that you as a software engineer do to build applications that go into making an AI agent, right? So I'll say this again, LLMs are a tool. They're not the product, right? They're not the agent, they're a tool. So you have to understand, as with any tool, what the capabilities are. So so that's the second piece, is like when you think about the AI agent, you have to think about leveraging the LLM in the right places. Then the third piece is, okay, so now you've figured out, okay, my large language model is going to help me with building a plan, for example, in the reasoning layer that we talked about earlier. So most AI agents today essentially propose a plan, and you have a human in the loop that then approves the plan. So a good example of this is a lot of the coding, co-pilots and coding agents that you have today. They're again, and particularly with the Claude Sonnet 3.5, that was like, I think, a step function jump in the ability of large language models to accurately generate code, right? The way they work is essentially, the programmer is interacting with the large language model. It proposes a plan which is approved and edited by the programmer before it actually goes out and executes it, right? So the so-called sort of user in the loop, human in the loop, is a very critical design component today in AI agents, particularly in that planning layer, right? Now, there are other things you can do, and we talked about part of this, which is, what we call like a reflection loop. So once the output of the agent comes out, you test it against another large language model, which is trained with the right output. So the agent essentially tests itself to say, did I get this right? And it's able to kind of think on whether the output is correct and then make those changes and go back and iterate again, right? So these kind of reflection loops, the way you build evaluations, which is how do you determine the output is correct? And using that data to continuously improve the AI agent is, again, part of the design process. So I gave you like three different things where you have to consider. There's a lot more we can go into in terms of depth, but at a broad level, the takeaway is that you can design AI agents to be deterministic, assuming that you understand the task,